All right. Hello, everybody. Thank you for joining us for today's webcast, CT Inspection Technology, Unlocking New Foreign Material Visibility. My name is Mike Lenz. I'm going to be the moderator for today's webinar, and excited to be joined by FlexXray's Chief Product Officer, Kye Luker, who's going to be diving into the advent of CT technology at FlexXray's facilities, what some of the best use cases are for this new foreign material detection technology, explaining some of the major use cases we've seen as we've looked across our different set of inspection projects, and explaining a little bit about how you can use it to make considerations within your plant around detectability and improving your foreign material outcomes. So we're going to give everyone just a minute or so to join. In the meantime, I want to talk about a few brief housekeeping notes. Throughout the presentation, you'll be able to submit questions for Kye to answer at the end of the broadcast using the comments box. So whether you're joining us on LinkedIn or within the StreamYard platform, please submit anything you have throughout the presentation. Some of them we may tackle as they come in, but certainly at the very end, we're going to tackle all the questions that are submitted to Kye. Again, whether it's related to CT, broader questions around foreign material detection and capabilities, just keep them coming and Kye will answer them all at the very end of the broadcast. So that being said, let's jump into today's presentation. First, I want to do a quick introduction of our presenter, Kye Luker, again, Chief Product Officer here at FlexXray. Kye leads the development of FlexXray's innovative X-ray inspection process and technology portfolio. And so when it comes to evaluating new detection capabilities within FlexXray facilities, Kye is the lead on this, spearheaded the implementation of CT across our network facilities, both in the US and soon to be overseas. So that being said, I want to kick things over to Kye to begin today's presentation and dive us into the nitty gritty on this exciting new technology. Okay.
Thanks, Mike. Excited to talk a little bit more about our CT technology. First, I really want to begin with just kind of a broad view of what we do as it relates to foreign material. And I'm going to speak, both from a FlexXray perspective, but also from a food processing perspective. And this slide really starts off with the food plant view and how we respond within the food system to what happens whenever a foreign material event starts. And it runs a broad spectrum of maturity. So as we begin with limited controls, our startup and shutdown checks and those types of things where we're doing check-based analysis or check-based approach, and continuing to improve that, inspections with physical barriers like screens or magnets, and then we get into automated detection. We're trying to improve or increase the opportunity for us to find foreign material issues before they become a widespread event. And as we build upon that theme, some of the things that FlexXray can do to help deepen this is aid and verification activities. We can help you understand exactly how your systems are performing and are they really executing the way that you want them designed to do so. And then lastly, proactive inspections, especially around supplier monitoring or new project startups, things like that, line extensions, we can really help and support the food industry in ensuring that there are no issues out in the field. Before we get into CT technology, I'd be remiss if I didn't just take a quick second to talk about inline X-ray inspection. Almost the majority of the facilities are still using metal detection, but with the advent of X-ray technology over the last 25 years, it really is a widespread adoption. And some folks are using both metal detection and X-ray to take full advantage. But for just a moment, the way an inline instrument works from an X-ray perspective is the image processing that's represented at the top of this visual. The strips of diodes across the conveyor are taking the image as it passes the product and creating an image and averaging the data from each one of those diode strips to create a composite image and ensure good detection rejection. There have been significant improvements, though, in the last few years with a different diode called a time delay integration. This is fully leveraged in photon counting technology that's in the marketplace now. And the main difference is it takes that information as it goes from one diode strip to the next and passes the data along as it goes. And so we improve the image quality overall. So instead of taking an average of each diode set, we're using the data that's created during each one in order to improve that translation. So overall, we get reduced noise in the image and a much more enhanced, finer contrast image overall. So if you're not leveraging TDI-based diodes in your inspection program from an X-ray standpoint through photon counting, it's definitely something to look at to continue to improve your inline inspections. So CT technology. I think everybody in the audience has a good understanding of two-dimensional X-ray. We're averaging that image density across the beam path that we mentioned a moment ago. But the problem with that is that the overlapping edges and contours of products, especially non-homogeneous product or product like a frozen entree, or in the image on the bottom left here, a bag of chicken tenders, there are places that objects can get masked or hidden that reduce the overall effectiveness of an inline two-dimensional X-ray. With CT scanning technology, we're running a gantry around that product, and then we can take and reconstruct individual 0.5 millimeter slices of the product. Look at that at an X, Y, and Z axis basis of the product. So essentially, we're getting a 0.5 millimeter slice on 3 different dimensional planes. We're removing the shadowing effect that occurs, and we're able to pinpoint items that were hidden previously. This allows us a significant improvement in the detection of glass, bone, stone, and really opens us up to a world where we can better detect rubber and plastics in a food product matrix as well. So we'll take a little brief view at exactly what's going on inside of the machine here. So the gantry on our CT technology, we're spinning this at 27 revolutions per minute. We have a 50 centimeter aperture. We can handle a box max width of around 16 inches and max height of around 13 to 14 inches. There are some changes as boxes narrow. We can go up in height just slightly. As product enters the imaging zone here, as you can see in this video, we start to reconstruct this image, and we can evaluate individual units as they pass through and make exceptional detection rejection. I'll let this video finish out for just a few moments, and then we'll speak a little further about the technology. Okay, so again, just to revisit some of the inline 2D X-ray inspection issues, we're struggling with density as it relates to overlapping product. There's a lot of low contrast problems as it relates to contaminants that are less dense that we essentially just have to let go, or we would create a high false reject rate if we went down to sizes, say, a 1 millimeter to 2 millimeter metal size that are easy to detect in a 2D X-ray. We can't quite go that low effectively at production speeds when we don't have a homogeneous image for things like bone, stone, glass, and then rubber gasket materials. That adds even more complexity. And then the detection scheme itself is limited because we're trying to focus on exactly one single kV MA algorithm setting at high production speeds. And so we don't have the opportunity to really dial in across a broad base of contaminants. We have to select the things that are the most risk, metal in this case, find the smallest ones, and then understand what sizes can we detect some of the other more difficult. So we may, again, be able to detect 1.5 millimeters of stainless steel with the 2D X-ray. For aluminum, we may have to go up to 2.5 or 3. For glass, we may be in the same range, and rubber gasket materials, depending upon if they have an additive, maybe at 3 millimeters or even higher. It is great, though, it helps us understand that a problem exists. So even if we can only detect a rubber gasket at 5 millimeters, at least we're beginning to understand what's going wrong if we have an inclusion in our product matrix. For a CT inspection, we're taking those effects out of the way. We can find low density contaminants by removing the overlapping image issues that exist with 2D inspection. We can also run a variety of algorithms that will help target specific issues. And then finally, this can be used for qualitative analysis as well, which I'll highlight in just a few minutes. I'd be remiss if I didn't say that there are some limitations as it relates to CT inspection. It has a much higher KV and MA than any inline instrument does. And therefore, when we get down to really small contaminants at 0.7 millimeters and below, depending upon the product density, we're essentially powering the photon right through the foreign object. So very, very thin diameter wire, like electrical wire pieces from a copper wire strand, or small pieces of stainless or ferrous could go undetected. But these sizes are extremely small.
All right, thanks, Kye, for that overview. As a next piece, we want to sort of jump into some of the specific use cases that Kye's mentioned CT is really exceptional at. So I see a number of you have been submitting different use cases or examples. I'd say let's hold on to those till the end of the presentation. If Kye doesn't tackle your specific use case within the next set of examples, we'll certainly come back and answer those questions. But as a next piece, we want to kind of look at first some broad areas where CT is really strong, and then we'll dive into some different industry use cases that we've seen across our different inspection projects at FlexXray facilities. So next up, I think let's tackle some of those high-level scenarios where CT really stands out.
Yeah, absolutely. So I'm going to talk a little bit about what CT can do overall and then get into those deeper use cases that Mike mentions. So why does CT really work well, and where does it stand out? We're really hammering this point home over and over again that we're eliminating the product layering effect. This is an example of a 1.5 millimeter gasket in a chicken nugget product. That would have been undetectable otherwise. Excuse me, Mike, having a bit of a coughing fit there. Glass and glass is the next place where CT really stands out. And here, we don't have to inspect single units. We can inspect a multi-pack, a 12 count or 24 count tray pack of glass and glass and find contaminants in the product zone. The algorithm essentially segments each one of the units out and then inspects the interior of the product. So we're locating the glass of the container, we're locating the metal lid, we're creating a framework for that composite image, and then ignoring the container itself. And lastly, Mike, if you don't mind, we'll go to the next slide. We can also do qualitative inspection with CT. So these examples are from the ice cream industry. We can ensure that there are distribution of ingredients properly throughout the product matrix. We can find issues with toppings on the outside. This one is an example of an ice cream product that should have a smooth surface appearance, and there are pot marks or defects where it was not applied smoothly. And then in the last image, the actual chocolate is broken on the outside. And for premium products, this is a quality issue that we want to avoid sending to our customers. So now we'll take a little bit deeper dive into where exactly FlexXray has found positive results with actual live examples from our customers. So first one here, we have some pork sausage crumbles. This is a 30-pound case, one bag in a box. Extremely difficult to image with the 2D X-ray. We have a lot of product depth. We have a lot of contours and contrast here. I have a piece of 3 millimeter gasket material. It has an additive in the gasket that allows it to be X-ray detectable, but that doesn't mean that it's X-ray detectable within that cased product matrix. As you can tell here, we have no visibility of that in the two-dimensional X-ray. But because we're stripping all of the product layering effects out, we can find where that foreign object is within the product matrix with the 3D image. And as you can see on the image on the right, And then the zoomed in portion, there's where the gasket was inside of that case. Next example is shredded cheese, which is extremely challenging in a two-dimensional X-ray. All of the contrast and all of the edges of the product tend to create a very difficult raw image in order to be able to process with an inline algorithm or even with the human eye. We have some sifter screen wire in this image, 4 millimeters in length. I believe the diameter on this is around 0.4 millimeters itself, so very small diameter wire as well. Completely lost in the two-dimensional X-ray. And then again, we can peel back all of those layers and we can find exactly where in the product zone that wire is. And this 3D example showcases the CT finding and locating that wire fragment. We've got a couple more that we'll showcase as well. Next, this is a processed food, a taquito, a burrito type product where it's a multi-pack, cartons in a case. You can even see in the raw image on the two-dimensional where the stacks of cases for the cartons that are below this are. We're looking for 3 millimeters of a gasket material. This one was a Teflon material gasket. And of course, we can't find that just due to all the contrasts and issues with product layering effects here. In the 3D image, we can strip all of that back and find that. And I'm showcasing the 3D here in two different planes. So we're looking at the cross section of the X-axis and the Z-axis, and the product is able to be found within the product zone here. We've embedded that in each one of these examples as well. So unlike traditional C-checks and a 2D X-ray, where we're placing that for an object outside of the product zone to ensure detection, rejection, leading, trailing edge on an inline X-ray, those types of things. For CT scanning, we really want to place that in the most difficult location inside the product zone, inside the middle of the container, to ensure good, complete detection. Lastly, one more example. Although pet food, especially kibble in this example, isn't dense, it has a very low grayscale rating whenever we image this product. There's a lot of air and a lot of dried fat that's inside of the kibble product itself. It does make for a difficult image because of how many edges we need to separate and look through layer product effect. So in this example, there's 3 millimeters of aluminum inside one of these bags, and we cannot find that in a traditional two-dimensional X-ray. And again, the three-dimensional capabilities of the CT, we're able to peel back those layers and find exactly where the location of that is. In fact, we could find smaller than 3 millimeters in this example from a CT perspective, but bone inside of the kibble product tends to be its own separate issue from an indigenous concern with inside this pet product. And we don't want to over-reject this product based on the customer needs.
All right. I think the next piece, Kye, is talking about some of these learnings. What are some considerations as FSQA managers go to think about their product lines, their production lines, to get more detectable, both within their inline equipment, but also when working with a third party?
Yeah, absolutely. I think it's an opportunity for us from an industry perspective to revisit components, materials that we're using, whether that's gaskets and O-rings that we're turning over on, some as many as at changeovers or at sanitation breaks, at least on a weekly basis, where we go through some of these high wear items. They could be something like a paddle inside of a scraper or a blender as well. There's an opportunity for us to evaluate that we're using materials that can be detected, because we're adding detectability at a much more robust level through CT. So now it's really time for us to take advantage of ensuring that we do have detectability within those. So auditing your parts and equipment components, obviously that's one of the things that's extremely important, and making sure that we're doing a risk assessment at the same time of the likelihood of inclusion there. Along with that, reviewing what can go wrong during production and ensuring that we have PM programs that are robust, that we have good feedback loops when things are starting to wear or when something is missing during a shutdown or a startup. Those types of things are extremely important. And then finally, I mentioned some of the X-ray detectable materials, and they're not always X-ray detectable at sizes or in certain materials. And we can help evaluate the actual detectability of those. So, oftentimes we're evaluating whether or not we can find an X-ray detectable, quote unquote, gasket material. And although that might be detectable in butter, which is homogeneous and high fat and easy to see through, it doesn't necessarily make it easy to find in a box of corn dogs, as an example. So we can really help explore the true detectable nature of some of those objects and improve your maintenance and quality plans. Another thing to consider here is that what's the ROI of CT inspection overall? We're now able, from a FlexXray perspective, to find things that we couldn't find from a material matrix standpoint. We can find things in smaller sizes as it relates to glass, stone, ceramic, those types of things, to ensure that you've got a good data set when it comes to the hold release of this. We can eliminate the false reject rate that comes along with the complexity in doing a two-dimensional X-ray with a CT scanning service. And overall, we're just helping the marketplace, helping ensure that your brands and your customers are protected as much as possible. And lastly, because the algorithms are robust and they are automated, we're providing you the best decision-making power that we can whenever we provide our reports back to you. So what are the things that happen whenever you have an event as it relates to FlexXray services? So the first thing, obviously in-house, you're determining the potential source. You're trying to bracket what that hold needs to look like around the product zones. The first thing that we're going to do in-house at FlexXray, though, is understand exactly what we can do as it relates to the capabilities of the foreign object and the product zone. And we're going to do that in and out of the case both to try to understand exactly what sizes we can get down to if we eliminate the product layering effect even further. So although CT can remove all those product layering effects, if we can eliminate the amount of product that we're having to pass a photon through, we can separate the density layers even further with less product. So even though CT is more capable than 2D, we can still improve the capability of CT by removing more product layers as well. And then obviously we want to understand what your internal size is and what the targets are. Did you grind up an object and you're trying to put all of those components back together again? Did you run that through a grinder or a pump where you've lost shavings and we're trying to find exactly when and where that may have occurred within the production run so that we can target the things that need to be disposed of properly and release the good product back into commerce? And of course, all of that comes with an evaluation of the value of the product, the cost of the service, and understanding exactly what the ROI is on letting that product out of your facility, be inspected by a third party so that you can get the best data set possible. So there obviously are some pros and cons of re-inspecting product internally. It's probably one of the biggest risks that we see day to day in the food industry. We've invested a lot of money and time and energy in installing X-ray equipment in our facilities. And oftentimes we see where people are leveraging a re-inspection on that same instrument whenever they've had a known event. That obviously isn't the best way to ensure that we found and captured where the product that's affected is within that hold or the lot that we've bracketed. But we understand that that is oftentimes a decision that's being made within a food plant. So I just want to reiterate some of the differences of even our two-dimensional X-rays whenever product is inspected at FlexXray. We're slowing the process down significantly, 100 plus feet per minute down to single digit, 3 to 5 feet per minute. We're able to find and locate metal objects down to 0.5 to 1 millimeter, and we're able to find other things that you can't find even down to 3 millimeters at sizes at 3 millimeters and below with our two-dimensional technology. Again, all of our products that we use for inspection technology are fully customizable. Our two-dimensional X-rays, we can manipulate KV and MA in a way to optimize image quality in a way that you can't with an inline instrument. And then with our CT scanning technology, we can dial up and optimize our algorithm performance to ensure that we're tackling the specific object within a wide variety of products.
All right. Well, appreciate Kye, you walking us through the technology when it comes to CT, some of the main use cases we've seen. It's been great to see a lot of comments and questions coming in throughout. So quite a few to tackle with our remaining time here. So I'm just going to start trying to group these up whenever possible. Let's start with a few that are about, how CT works. What are some of the capabilities there? So first one is, what does the process of training the system look like for specific product lines? So in short, how does it learn to detect defects in the products?
Yeah, absolutely. So the algorithm works in 4 distinct ways, and I'll talk about the easiest one first. We're evaluating the density of the product, the density of the foreign object, and we want to try to create enough disparity in that gap to ensure good detection. The lower that we shrink that gap, there are opportunities for false rejects to occur, or we need to increase the size of the foreign object in order to get that threshold difference back. After that, we're looking at individual planes and pixels adjacent to one another. And so we're evaluating pixel to pixel and then plane to plane within the product zone to try to build or reconstruct the foreign object in a 3D perspective. So in CT technology, we're using the term voxels. So all of the blocks, in essence, the cubic pixelated 3D reconstruction, so that we can actually understand if something is 3 millimeter spherical, are we finding all 25 voxels that we need to find in order to locate that? And then we're essentially adjusting those thresholds to optimize detectability. Depending upon the product density, we're adjusting those thresholds up and down.
Okay. A couple more questions about sort of capabilities and how the technology works overall. So one is what validation methods and performance data are available to demonstrate CT effectiveness for foreign material detection? How is this typically accepted food standards like SQF or GFSI?
That's a difficult question to answer outright because there isn't a set standard from a methodology perspective. Every engineering group within the food industry is going to approach a gauge R&R study about the effectiveness of their own inline instrument, and you're setting up the success criteria for those. For us at FlexXray, as it relates to detectability of a foreign object within a product, we're essentially imaging the product in its most difficult location in the center of the box and ensuring that we can detect that and separate the density levels high enough. So I'm just going to use some numbers for easy math. Let's say your product density has a grayscale threshold of 1,000, and the foreign object that we're detecting, say 1 millimeters of stainless steel, as at 2,000. Well, that's a significant disparity between product density and foreign object density. We're going to find that 100% of the time. There's no way that that can be missed. The issue is that we're shaving pieces of metal and presenting fragments and shrapnel inside the product matrix, and we're trying to detect those things as well. And those are amorphous. Those are of varying sizes and shapes and different densities as well. And for something like ferrous, they could be oxidized, which changes some of the features for detection. So whenever we set up a recipe, we're really trying to get down from a detection standpoint as close to 200 as it relates to that. So we ensure that we find all of the potential pieces of shrapnel that we can, even if that's 1 to 2 single voxels or a half millimeter cube of data within inside that product zone. Now, if there are statistical challenges, we work with individual customers as it relates to the size criteria that we're establishing, and we can do replicate studies.
All right, appreciate that. I think we're going to jump into a few more, time permitting. So, obviously when we talk about CT here at FlexXray, we're talking about it in use in a FlexXray facility as part of an offline inspection program. So for people interested in, how this technology applies within a plant setting or within a production line, you talked to a little bit about that. How does it fit in as part of a CCP or verification step or an investigative tool?
Yeah, if I were to purchase one, I'll go back to my previous life in QA in a plant environment. It's large. There are very few places, very few plants that I've been into that it would fit inside, a production line setting. That's not to say that they can't be leveraged that way, but we're typically running in the 20 to 30 feet per minute range from a CT standpoint, and that's just not conducive to maintaining what we see as typical production speeds. But if you had a bespoke product or essentially very expensive or high valued product and you had the space, you could use a CT inside your own production environment. The cost, the size, the capabilities of it, it's best, in our opinion, serviced as an offline instrument. And that's how we maximize the opportunity.
Oops, sorry about that, was on mute. So with a few more minutes left here, let's jump into maybe a few of the specific use cases that people are asking about. So I'll kind of just throw these at you rapid fire, Kye, the best you can answer, the best, however you can. First one is specific to wet jerk seasoning and jerk sauces and, CT's capabilities with that type of material.
Okay, let's say they're bottles, glass and glass. We would essentially work with the manufacturer and our engineering team to build the algorithm to understand the bottle profile, where the cap, where the bottle contours are, basically have the machine learn what that profile looks like so we can ignore the container itself and then look for defects inside the container. If this was bagged product or plastic jugs, things like that from a CT scanning technology, although oftentimes these are very dense, could be high sugar, high salt content that make it very difficult for a 2D X-ray to inspect product in, because we're peeling back all of those layers. We've had high success with inspecting these types of products already.
Okay, let's throw a couple more at you. So I think this kind of relates to qualitative inspection. So someone asking about natural crystallization in products, whether CT can see that, as we look through a case of product.
So it depends upon the crystallization issue. If crystallization is a potentially naturally occurring issue and is present in the product, it can make detection difficult. There are certain types of crystalline structures that are going to look very dense and appear as a foreign object. So we oftentimes have to work with those thresholds and go up on some of the foreign material profiles in order to ensure good detection. Now, if crystallization is a one-off defect, then CT is exceptional at finding, that presence in the product because of the way that crystallization tends to, have a nice density profile under CT.
Okay. Everybody, we've got more questions than I think we have time for here. What I would say is that we'll have Kye or someone from our team reach back out on any of these remaining questions, because I know you have some very specific asks here. I think one question, for folks who are already working with FlexXray on different projects or have worked with us in the past, how does this impact working with FlexXray as a third-party partner? Is this something that a customer would need to ask for, or explain sort of the process of how we integrate CT into our services?
That's a good question, and I'll try to answer as quickly as I can. Everything that we receive as far as a foreign material and product combination, we're going to image on a 2D imaging device. We have more of those available on our network, and we just want to establish detectability in kind of the quickest way possible. So if something is detectable in our 2D setting, we're also going to leverage CT technology whenever we have open capacity. If something fails to be imaged in a 2D setting, we're automatically going to CT test that every single time at FlexXray. And if we have to take something out of the case, which is going to add excess labor or slow down the throughputs, we're going to evaluate CT capabilities to keep that product in the case to ensure good turnaround time of your product so that we can get it back in your hands quickly.
All right. Well, again, thank you everybody for attending, for Kye presenting this information. Like I mentioned, if we didn't get to one of your questions or comments, we'll do the best we can over the next couple of days to reach out directly. Want to make sure no question goes unanswered. So I really appreciate everybody's time this afternoon, morning, depending where you're calling in from. We continue to do these webinars on about a quarterly basis, if not more frequently. So it's great to see so many familiar faces jumping on now as we did last year. So keep an eye out for future invitations on other topics. And if you've got anything specific to CT, please be sure to visit our website and submit a contact us inquiry there. We can get back to you with the appropriate information, with the right person. So again, thanks for everybody's time this afternoon, and hope to see you next time.